Hello to you all, wonderful and awesome Mindsetters. It's yet another beautiful Monday where we call it a Triple M day. It is Mindsetters Matt Monday, and you are tuned in. As Abram, I am the host for today, and I'm joined by Dina. How are you, Dina?
Hey, Abram. I'm doing very well and very excited for this afternoon's show.
It's going to be a great show, trust me. And what are we doing?
We're going to be looking at one last time matrix, a preparation of paper 2. So we'll be looking at some analytic geometry questions, some trigonometry, and if we've got a bit of time, we'll even look at the angle of rotation.
Awesome. Let me tell the Mindsetters that as we're revising, if you'd like to get on more revision packages, get onto the Learning Hub, which is probably brought to you by Samsung. As you know that we have a competition also. If you don't have any device, we'll be giving away this week a Samsung tablet. All you need to do is to download today's notes. The link will be posted on Facebook, and also enter into your entry for post your entry form on www.mindset.co.za/learn/win. And otherwise, for you grade 12s, you also have another exciting thing that you need to do for us. You need to go to Curio, fill in the assessment, and let us know. There's about 5 questions now, and the first person to get them at the fastest time will get a 100 Rand voucher. That's so cool, awesome. But otherwise, overall, we're going to be having an awesome S3 that we're giving away. So make sure that you go into Curio. The details will be posted on facebook.com/LearnExtra. And another thing is you need to follow us on Twitter @LearnExtra. But for now, let's learn.
Thanks, Abraham. Right, grade 12s, it's happening. It's within the next 12 hours. You'll be writing that paper 2. So let's get to it. What more can we cram into those little heads of yours to get through tomorrow's examination? So let's get straight through paper 2 questions. So the aim of today's lesson is really to work through various questions in preparation for your paper 2. And the first question I've taken from, or that we've taken, is from the supplementary paper, paper 2, question 4. And to get us familiar with what's happening in the given, let's read through it together. In the diagram below, trapezium ABCD has got AD parallel to BC. And grade 12s, I think you're familiar with this. We need to highlight all the important pieces. So key things like AD is parallel to BC. We want to not forget, because it carries quite a lot of information. So with any analytic geometry, remember parallel lines and perpendicular lines, we work with gradients. So we want parallel lines for gradients to be equal. We want perpendicular lines so that the product of the gradients is -1. So we want to look for those key features. The coordinates of the vertices of that trapezium are that A is 1, 7. B has got values of PQ, C has got values of -2, -8, and D has got values of -4, -3. And then we've also got something important, that BC intersects the x-axis at F. So we've got an x-intercept right here, and then we've also got an angle that's been given. Right, let's get onto the diagram and see that all information is there. There's my trapezium with a set of parallel lines. I like that because grade 12s, as you're looking at that, what are you saying to yourself? What is it that you know about these 2 pink lines? And that is the gradients are equal. So the gradient of AD is equal to the gradient of BC. It's important to kickstart the question by extracting as much information as you can before you even go into the questions, so that you're making sure that you're connecting the given to your knowledge base, and that you're not just leaving certain things just out there. Okay, so the first question is to calculate the gradient of AD. So gradient of AD, we would say that it's the change in y over the change in x. And we would certainly look at those 2 points. So y of A minus y of D divided by x of A minus x of D. Now, grade 12s, this is the one last time you're going to ever be writing these gradients. So make sure you've got change of y over change of x. I will be marking your paper 2, so I'll be watching for your script. And just make sure that you haven't interchange the x and the y's, because it's so sad when you know what you're doing but you've just mixed them up, and then your gradients don't fall into place, and then the next question, which is needing the previous question's answer, just goes completely wrong. So make sure that certain things like formulae, that you're going to your formula sheet, you're verifying that you've got the right fraction. change of y over change of x. So we're going to now just substitute. Grade 12, so important to do the substitution correct. So it's the 7 plus the 3, and it's the 1 plus the 4. So we've got the 7 plus the 3, and we've got the 1 plus the 4. So we'll end up with a 10 over 5, which is just equal to 2. Accuracy, accuracy, accuracy. Make sure that those values that you're working with are the exact values. So if we go back and we check, are we happy that this gradient is 2? If our answer was negative 2, we'd know we'd have made a mistake. But 2 looks okay. The slant of that line looks fine. So let's carry on with the next question. Determine we need an equation of BC, and this is a straight line. Okay? And we need to have it in the form y equals mx plus c. Again, the instruction's the most important thing. It doesn't matter that you've done 20 of these questions the night before your exam. What really matters is that final question that you're now answering in your exam, because that's the one that will be marked, and that's the one that counts. So make sure that you're answering the question, that you're not trying to do something, because you know something about lines, you think it should be like this. Grade 12, that's the biggest mistake you can make. You begin thinking outside the instruction. So the instruction is very clear. It's the equation of a straight line, and they specifically want it in that form. I would also suggest grade 12s that once you've done the question, go back, reread the question, and see that you've actually answered it. Because sometimes there's quite a lot of working, and then we arrive at an answer, we go on to the next question without finishing it off and making sure that we've read what the instruction is. Okay, so the equation of BC, how do we tackle BC? BC is one of these lines that is parallel to AD. So we've already said at the beginning that because we've got parallel lines, because AD is parallel to BC, we already know the gradient of both those lines. That's what we found out right at the beginning. So in this part here, we can actually start off by saying that the gradient of BC is equal to the gradient of AD. And now grade 12s, you must have a good reason for that. You must say that BC is parallel to AD. Okay? No mark will be given for a statement if it doesn't have a reason with it. So we've now worked out gradient of AD is 2. So therefore, both these gradients are 2. So the gradient of BC is also equal to 2. Now, if I have the gradient, then all I need to do is get my y-intercept. So y at this stage is equal to 2x plus c. Okay, give us some instructions. I'm going to now substitute a point that is on the line. And what point is on that line? There's BC. Can you see point C is on the line? So I can go down and substitute point C, which is, I forget the coordinates now, -2, -8. So we're going to substitute -2, -8 into this equation here, into equation 1. So we now have -8 equals to 2 times -2 plus c. So we get c is equal to -4. Because there's a -4 there, add on to that side, I get -4. So therefore the equation, finish the question, it's said in that form. Grade 12s, if you leave it here, you're not going to get full marks because you have not answered the question. So go back to that question all the time. So to finalize your answer, if the gradient's 2 and the y-intercept is -4. So that's the equation of this line. And as you're finding things, go back and write them on. So the equation is y equals 2x minus 4. Are we happy with that? Well, the y-intercept of this pink line is on the negative side of that y-axis. So I'm happy to a certain degree that I haven't got it in the wrong place. Obviously, if I had a +4 there, I would have really thought about my arithmetic and gone back to check. But I think I'm relatively happy with that. Then, next question is, determine the coordinates of point F. Okay, again, grade 12s. Your answer needs to be finalized like this. The coordinates are. Without the coordinates, you will not be getting that full mark. And notice it's only 2. So if you don't answer the question in the format it gets asked, then you will not get full marks. So coordinates means the coordinate pair in that form. And what is special about point F? point F is the point where the line intersects the x-axis. So if it intersects the x-axis, then that is the point where y is equal to 0 on that yellow line. So when y equals 0, what is happening to x? If y is 0, then we get 0 equals to 2x minus 4. So 2x equals 4 and x equals 2. So we have that the coordinates of f are 2, 0. Okay, that's just in thinking mode. So that would be equal to 2, 0. Okay, so we've looked at three things. We've looked at gradients and the power of gradients in analytical geometry and how you should be trying to exploit parallels and perpendiculars. We've looked at the equation of straight lines. There's always going to be straight lines. And we've also looked at how to find coordinates of points if you're looking for intersections, intercepts, that kind of thing. Let's look at what's next. Okay, so we've looked at those lines. Okay, so there's two more questions. We need an area and we need to find an angle. Okay, so here's the diagram once again. And we've worked out that the gradient of this line here, the gradient of AD, is the same as the gradient of BC. And it's both 2 in each case. Okay, and now all of a sudden we're being asked to calculate this angle over here. Now, analytical geometry is really one of those sections where you can really incorporate other ideas. So some of you may be thinking that you could actually work out the length of each of these three segments because we've got all the coordinates, and then you would use the cos rule to find that alpha. Okay, that's one way of finding the angle if you had all three segments. I'm going to try and use something a little bit different. And that is, every time you've got an angle, what is that tool in analytic geometry that helps us to find angles? Okay, your tool is your inclination. So I can find my inclination to my x-axis. I can find this angle, and I'm going to call it I'm going to call it theta. So I can find that green angle. Now, if I have the green angle, do you agree with me that these lines here are intersecting? So therefore I would also have this green angle over here. It would also be theta because they're vertically opposite angles. Now if I had this angle, then the way that this angle here is connected to this alpha is if I just do a little extension of this line, because I also know how inclined to the axis it is because I've got these 2 points, I can work out its gradient. Instead I've got this angle here as beta, and inside this little triangle is the theta alpha that actually connects to beta. So that is one way of you being able to work with angles, is to try and create all the inclinations with the x-axis that you can possibly find. So that inclination is the same as that one. That's also theta. Let's just do that. So this one's also theta because the lines are parallel. And then these lines are parallel, so those angles are alternate. So can you see I've found every single inclination possible. And once you've got all the inclinations, you can actually see, well, how are the other angles connected? Okay, so this inclination, the definition of inclination is that tan theta is equal to the gradient of BC, which is equal to 2. So theta is equal to, your calculator will give you that quite easily. We've got a tan function of, we said, 2, and I think that's about 63. Let's just see. Yeah, 63,4. So that's 63,4 degrees. And then this line here, we haven't worked out what the gradient of DC is, but the tan of beta is the same as the gradient of DC, which we could actually work out quite easily. Change in y, negative 8 plus 3 is negative 5. And change in x, it's negative 2 plus 4 is negative 2. So it's actually something's not right. Negative 8 plus 3 is negative 5, and negative 2 plus 4 is positive 2. There we go. And we can actually check now what that angle is. So we've got a second function, tan, and we want it of 5 divided by 2. And what do we get? That's a 68. but I've included my positive angle, and I can actually see that my angle here is obtuse. So I need to minus that from 180 to get my obtuse angle. So it's 111,8. Okay, so beta is 111,8, which then from our calculations with the green and the orange angle means that alpha is actually equal to 111,8 minus our theta value, which is 63,4, and that gives us a total of plus 63,4, and we've got 48,4. And I think the question said show that it's equal to 48,4. So I think on that note, we'll take a quick break.
Thank you so much, Dina. Well, Mindsetters, let me tell you more about the LearnXtra Exam Marathon competition that we are having in partnership with Samsung, where you could win one of these awesome devices. We've got 3 tablets that are up for grabs and 3 tabs that are up for grabs. And also we have now one Samsung Galaxy Note 8.0 that is up for grabs. So we are on leg 3. Make sure that you enter. As you can see here on this Samsung Galaxy, you can go to our Learning Hub where you can access some revision material that we have as Mindset. This is just a shelf of my stuff that I have downloaded on my tablet. Like as you can see, there is a grade 12 physical sciences paper 2 chemical industries, which has a review. There's also some you can also see some incorrect answers and some notes, question and answers that you can view on this tablet. So it is an awesome tool that you can have and you can download. If you don't have one, don't stress, because that's why we're having the competition. To enter, you simply need to download your notes, of which the link is posted on Facebook. And secondly, fill in the entry form on mindset.co.za/LAN/win. You should be knowing it by now. You have to have a race number. And because you guys are grade 12s, I'm going to give you guys the race number. It's just going to be somewhere on the page so that you do not have any excuses. Otherwise, we'll see you after the break. Welcome back, Matrix. Now, I'd like to know, how are your exams going? Because, you know, as Mindset, we're going the distance together. We'd like to find out from you. As I just saw the comment from Nsovo on the page saying, this is my final lesson, preparing for my final paper as a final year of the final grade in high school. Just enjoying more info from you, AP, and together with Dina. I say hi to you too. So thank you so much, Nsovo. As you're enjoying and preparing, make sure that you also ask us some questions if you're struggling anywhere. Go to our Twitter and submit, Facebook. You can go to Facebook or Twitter, follow us on Twitter. And if you're struggling, also we have a help desk on Mixit. Otherwise, as matriculants, last thing, Curio. We have this assessment. You need to go to m.curio.co.za, fill in the assessment, fill in those answers, and let us know so that we can see if you're struggling and you could win 100 Rand worth of airtime, a voucher. So, Dina?
Right, grade 12s, how's that analytical geometry coming along? We didn't do one of the questions from that paper, which is the area, so let's quickly get to it, because I really like the fact that this section integrates quite a lot of the trig. So we spoke about the previous angle, that we could actually use the cos rule to find the angle if we had all the lengths. Well, it's the same thing with this question on calculating the area of DCF. So if we go back to DCF, DCF is this blue triangle over here. And how do we work out areas of triangle? Well, we know the very popular one area of is length of base times altitude multiplied by 2. I'm not going to create any perpendiculars. I'll leave you to that in your exam tomorrow. But I would like to revise that to find the area of that triangle, if I've already been given that angle, and they did because they told you to show that that's 48,4, then I really want the length of that and the length of that, and I can use my area rule. Now, very important, the area rule goes together with sine. In grade 12, you've got no excuse. That formula's on your sheet, so make sure that you get the right formula. Okay, so the area of triangle DCF then will be the length of the one side, which is CD multiplied by the length of CF multiplied by the sine of angle C, and then we've got to take a half of that. So that's the formula. Let's just double check that C is the angle. Yes. So I've got CD and I've got CF. So now I need the distance of CD and I need the distance with F. So DC squared is the change in those, so it's negative 4 plus 2, which is negative 2 squared, which is 4, plus, and the change in those, that would be 5 squared, so it's 25. So DC squared is equal to 29. And then I've got that CF. And remember, we worked out these coordinates were 2, 0. So the change in x, 2 plus 2 is 4 squared is 16, plus 0 plus 8 is 64. So that length there is 100, the squared of that. So just double check, minus 4 plus 2, and change in the y, so it's negative 3 plus 8, which is 5 squared, so it's 25. Okay, keep going. So it's the square root of 29, the square root of 100. So it's a half of the square root of 29 times the square root of 100 times the sine of 48, comma 4. Let's see what we get out of that. Very important, grade 12s. Formula number 1. Tell the person who's going to mark your work how you have substituted. And then finally, let's use our calculator to help us out there. So we've got 0.5 times root of 29 times root of 100. It's very important, grade 12, you've got to get out of that square root, times the sine of 48.4. And let's see what happens. Well, we get 20,13 or 20, they will want 2 decimal places in your exam unless otherwise instructed. So I think we're going to make it 20,14. 20,14 square units. Unless they've specifically given you meters or centimeters, then you can square the units. Okay, so we've got that. And then let's get on to our next. So tomorrow you are going to get something around lines and angles and inclination, and then you will get something around circles, because circles are another big section in analytics. So remember the equation of the circle. It's always x squared plus y squared equals r squared if it's the parent graph where the center is at the origin. But when that center translates up and across, then your equation becomes x minus that center A all squared plus y minus b all squared equals to the radius squared. Again, that formula is on the formula sheet, so nothing to be worried about. Okay, so here we go. Question from the supplementary, question 5. And they speak about circles C1 and C2, and I go down to my diagram, and there's no circle there. So had that been your final exam, I know that you'll be totally thrown. It's very important to work on your diagram sheet and to make sure that anything you are using in the diagram sheet is visible to the marker. As much of the working, your thought processes that the marker can see, the better your chances are of getting marks. So we want you to be able to work on the picture. So we'll look at it in a moment, but as you can see, there's no circle there, there's no circle 2, there's no circle 1, there's just some lines that have been drawn for us. Okay, so we've got circle C1, and we've got circle C2, have the same center M. Okay, so what does that tell you? Okay, that whatever the coordinates are of that, I can actually find an equation for each of those. I can say that x minus the x of m all squared plus y minus y of m all squared is equal to r squared for both. Both have got the same center. P is a point on C2. So C2 has got P on it, and PM intersects C1. So there's an intersection of a line at a particular point. And then we have a tangent to C1. So we've got this tangent to circle C1, and it intersects C2 at B. Lots of information to get through. The equation of the circle, this gets now interesting. Equation of the circle C1 is given by x squared plus 2x plus y squared plus 6y plus 2 is equal to 0. And there's also an equation of a line, PM is y equals x minus 2. So let's make sense of this. Here's PM. That's that line there. And here's M, that's center for both circles. And if we go back and just read what they say about what's happening to the tangent dB. So tangent dB, this line, is a tangent to C1. So from that information, what did we do C1? C1 was the blue one. So I can actually say that equation C1, or circle C1, must be doing something like this. No, it's not doing something like that. It's doing something like this, because that line is a tangent, and it's got M as a center. So I can, in a preliminary phase, just say I do know that that's a tangent. That's been given to me as a tangent. And I want you to write tangent, because grade 12s, what powerful information do you have as a result of knowing that a line is a tangent? Yes, you're going to take that with you tomorrow, is that a tangent will be perpendicular to the radius. And when we started this afternoon, we said we're looking for perpendicular lines, because the gradient of the tangent multiplied by the gradient of the radius is now going to be -1. So this word tangent is loaded with information, okay? It's got lots and lots of information. It's got perpendicular lines, tangent and radius, and then I can work with the gradients in order to set up an equation. So can you see how much information I've already put on the diagram as a result of my given? Okay. Now, the next thing is, can we find, if I've got the equation of the circle, can I find its center? Yes, you should all be shouting, of course we can. We just need to complete the square on each of the quadratics, and then we're there. So let's do it. We've got an x squared, and that's actually the first question. It says determine the coordinates of center M. So the equation is x squared plus 2x plus y squared plus 6y plus 2 equals 0. Okay? You're going to complete the square, so you're going to have a square bracket and a square bracket to work with. We want a square bracket in x, we want a square bracket in y. So what do we do to this to complete the square? We take half of 2 and we square it, so it's plus 1. And on the side, we take half of 6 is 3, 3 squared is 9. So I'm adding 1 and 9. I'm adding 10 on the left, so I'm going to add 10 on the right. This little positive 2, he's got to go over because he doesn't really play a role in the completing of the square at all. So we now have x plus 2x plus 1 plus y squared plus 6y plus 9 is equal to minus 2 plus 10. So we now have the factored form x plus 1 all squared plus y plus 3 all squared is equal to 8. And so we want that magic binomial squared in x and binomial squared in y in order to get to the center. So where is the center now? Okay, the center is not this value because the formula is in the form x minus -1 squared plus y minus -3 squared is equal to 8. So our center is -1, -3. It is never what those signs are. It is the translation in the opposite direction. So our center is therefore the point -1, -3. Let's go back to the picture. What do we get up here? Yes, it's third quadrant. So x is negative and y is negative. Just so important to us that those signs are correct. Okay, so then what is the radius of that blue circle? Okay, well this gives us the center in the quadratic. This value at the end here, this 8, is radius squared is equal to 8. So it's not the radius, it's radius squared. So your radius is equal to root of 8, or in simplified form, 2 root 2. And whenever we're talking about lengths in analytical, we'd like to leave them in third form, just a little bit more accurate to say them in that way. Otherwise, if it's not in irrational form, it won't really be the exact value because you've had to round off. Okay. Then, determine the coordinates of D. Yes, tell me more about D. What's D? The point where the line and the circle intersect. Now, grade 12s, you're very good at expressing yourself when you're doing any graphs that intersect. What do you do algebraically? How do we express this intersection algebraically? Okay, a line and a circle intersect when the y value of the line is equal to the y value of the circle. In other words, they share the same y value. That's a point of intersection. The circle and the line can be doing all sorts of various things, but when they intersect, the y on either graph is actually the same value. So I'm just going to use that understanding that the y of the line is equal to the y of the circle. So let's go and find the y of the line. Y of the line is x minus 2. So y equals x minus 2. I'm going to substitute this into the equation of the circle. Okay, and I've just found out that my equation of the circle is x plus 1 squared plus y minus 3 squared plus 3 is equal to 8. So in place of that y, I'm going to just substitute in x minus 2. So I get x squared plus 2x plus 1 plus, can you see that if I put in an x minus 2 here, I'm going to have an x minus 2 plus 3. So I'm going to have an x plus 1 squared is equal to 8. Okay, and in fact, I can actually just undo that for a little bit. If we just keep this like that, because I've noticed something that we can do quicker. So if I have this as x plus 1 squared, then I have two of them. 2 of x plus 1 squared. They're like terms. These brackets are the same. So instead of multiplying out, I can just add up easier that way. So I get x plus 1 squared is equal to 4. And then I've got a square on either side. So I'm saying that x plus 1 is equal to 2, or x plus 1 is equal to minus 2. So x is equal to 2 minus 1, which is 1, or x equals minus 2 minus 1, which is equal to minus 3. Those are the x values. What are the y values? Well, we originally said that they will be the same on y equals x minus 2. So if y equals x minus 2 and x is equal to 1, then 1 minus 2 is negative 1. And this one, x minus 3 minus 2, then y is equal to minus 5. So we're going to have two possible points. We're going to have 1, negative 1, and we're going to have negative 3, negative 5. Let's see which one suits this point the best because of its position on the Cartesian plane. So D is actually the point, was it D or B? Let's just go back and check here. D, the point where the line and the circle intersect. So this point we're actually finding is where x is negative. There it is, negative 3. So this point must be the point negative 3, negative 5. Does it make sense? Because we just earlier had the center of negative 1, negative 3. So yes, you've gone across, you've translated left, and you've come down. So negative 3, negative 5 certainly seems to be the correct point for D. I think we'll break it off there.
Thank you so much, Dina. On the page, I see the mindsetters are on fire and they're learning so much. Let's keep that attitude and know that if you have done a certain question, like you've been saying, so will help other mindsetters on the page, because that's the spirit of mindsetters. Otherwise, take a short break, enter for the competition. We'll see you after this. Welcome back, awesome mindsetters. Now, if you're still struggling about how to enter for the competition, simply go to mindset.co.za/land/win. You should be knowing it by now. The race number is somewhere on the page. You know that up for grabs, it is a tablet, probably brought to you by Samsung, going the distance together. Let us know then, how are you getting ready for your paper tomorrow? Are you still struggling? Let us know also on the page, facebook.com/learnextra. Dina?
Well, grade 12's time is rushing by, and we're just having so much fun here working with tangents and radii, and we haven't even begun to work with the property of that tangent and that radius. So the second question was around, well, there's no second question here. Oh, here we go. If it is given that dB is 4 root 2, so we're given that length dB, determine what the length of MB is, the radius of circle C2. So we're now given that this length here, dB, I'm going to put it in green. Okay, now let's remind ourselves what's happening here. M was the center of both circles, and that just means that they're concentric. So we've got M is -1, -3. We've worked that out. We've also found that we were told, we didn't find anything out, we actually were told that this line, this green line, was a tangent. And we said right from the outset that a radius is perpendicular to a tangent. Therefore, the gradient of the radius multiplied by the gradient of the tangent is equal to -1. Grade 12s, it's not radius times tangent is -1, it's their gradients, okay? But most importantly, if we have got perpendicular lines, then what we're saying is that this radius and this tangent are at right angles. So that's at right angles. And now that's very powerful, because you know the very, very important right angle triangle. In mathematics, we are always using Pythagoras. And it appears that we're going to be using some kind of Pythagoras, because they've told us that dB is 4√2. So we know that this length here is 4√2. That was given, 4√2. We can work out what that length is, and so we can find out what the hypotenuse is. So let's just use a little old Pythagoras, and let's just say, tell the marker what you're doing. So you're in triangle MDB. We've got that angle MDB. MDB is equal to 90 degrees, and why? Because the tangent is perpendicular to the radius. Therefore, we would have that the hypotenuse, MB squared, should be equal to the other length squared. So we actually got dB squared and dm squared. dB squared plus MB squared. And dB squared, they told us, was 4√2. So if I square that, I'm going to get 16 times 2, I'm going to get 32. Now, MB, we've got to go and do a little bit of calculation. We haven't done that yet. Actually, it's not MB, it's MD. Hey? MD, let's just be accurate. Oh, you are writing an exam tomorrow. Let's be very accurate. MD squared. Right, MD squared, it's the change in x, so it's -1 plus 3, so that's 2 squared. So it's MD squared is 4, and -3 plus 5, it's also 2, so it's plus 4. And I really didn't have to do that, because MD was just the radius of that blue circle. You'd be telling me, yes, we could have sped things up there. So that was just the radius of the little circle, which is equal to 8. So MB squared is equal to 40. Okay, and so MB is equal to √40. And let's go and look at the question. What do they say? Determine MB the radius. They have not told you how to leave MB. So guess what? When they don't tell you, you can leave it in its simplest form. Okay, so that's 4 times 10, so that would be 2√10. Leave it in its simplest form. Okay, then write down the equation of circle C2 in that form. Okay, well, circle C2 has now got that yellow length as that we worked out as its radius, and it's got its center. So we really don't have to do much work there. We've been told that the center was 1 from the previous question. We've got y plus 3 all squared, and we've just worked out that the radius is √40, so it's equal to r squared, which is just equal to 40. So that's the equation of that circle. And then is this point 2√5, is it inside that circle? And support your answer with calculations. So for these 4 marks, grade 12s, we can't just say yes or no. We've got to support some kind of calculations. How do you know whether a point will lie inside or outside the circle, or it's lying on the circle? Well, if we take its y value, if we substitute its y value, and we get the same x value as on the circle, then we know that that would be a point. But the most important thing is we've now got that this equation, x plus 1, y plus 3 is equal to 40. That's the equation of C2. So we've got x plus 1 squared plus y plus 3 squared is equal to 40. We are saying that if the point is going to lie on the inside of the circle, then its radius wouldn't be root 40. Its radius would be shorter than root 40. Therefore, radius is less than root 40. Okay, so that's what we're going to go and look, is the new radius of that circle. So I'm going to substitute the point 2 root 5. So 2 root 5 plus 1 all squared plus 0 plus 3. Sorry, I should have said substitute f here. Substitute point f. And what are we going to get? Well, our calculator will certainly be able to help us with this to get a very closer value. So 2 root 5 plus 1, and we want to square it. And we get that, 21 plus 4 root 5. And now we want to add it to 9 plus 9 equals. And it's 30 plus 4 root 5. I don't feel happy. We can't compare that to root 40. So let's see what our decimal version is. So we get a 38,94. Can you see? That is our radius squared. So if we took our square root of the answer, we would get a radius of 6,24. So that would give me, therefore, the radius is approximately equal to 6,24. And what did we say? That if the radius is smaller than that, then the point will be inside the circle. Therefore, f is inside the circle. Okay, because I've already mentioned what I'm going to be looking at if the point's inside. If the point is outside the circle, then what would happen? A point that's outside the circle, you would have the new radius being longer than root 40. And if a point is on the circle, then when you substitute that point, then your radius would be equal to root 40. Okay, so it makes sense. If a point's on the inside, the point is giving us a radius that's smaller than the actual radius of that circle. Okay, right, and that was our circle. So let's move right along and let's go and see what our trig has to offer. Okay, again, I'm taking it from the supplementary exam. I thought that was the latest paper, and I thought that the examiners may be having the same kind of mindset, but we never know. Your paper could look very different, but the knowledge doesn't change. Things can look different, coefficients can change, constants can change, but sine squared plus cos squared equals 1. That won't change. So let's have a look at the key things that you need to take with you as you go into the exam for trigonometry tomorrow. First question, simplify as far as possible. How far can I go in simplifying? 1 minus sine squared plus 3 minus cos squared. Okay, so we've got a 1 minus sine squared, and it is important, grade 12s, to be looking at that formula sheet all the time, not forgetting any of the important identities. And the most powerful one that you'll ever find is that sum of the squares of the trig functions. It always amazes me. I'm always getting excited that I'm seeing this quadratic function. Why should it be that sine squared plus cos squared equals 1 all the time? It's really fantastic. Okay, so 1 minus sine squared is equal to cos squared. And then I'm adding 3. And I'm subtracting cos squared, so I get these two like terms. Cos squared minus cos squared is 0, so I'm left with just a 3. 2 easy marks there on the trigonometry. Right, then simplify without the use of a calculator. We have 4 to the power of sine 150 times 2 to the power of tan 225. And we needed to work out what that value was. Okay, so I'm just wondering if that was 23 or 2, but I think I recall seeing that as a 2. Anyway, let's go through to the next question. We'll come back to that one just for me to rectify that. Okay. We've got prove that cos squared x times sine squared x plus cos to the 4x all over 1 minus sine x is equal to 1 plus sine x. So we've got the old faithful identity. There's no doubt about it. Tomorrow you're going to get into your exam. There will be an identity for you to prove. You're going to have to prove some side equal to the other side, or both sides you've got to work out, but you've got to try and simplify. You've got to add, subtract, multiply, divide, and where do we begin? We begin with any of the algebraic properties we see. So if we have a fraction and we have more than one term in the numerator, how do we divide? We divide by having factors. So where there are terms, we want to make sure tomorrow that we're only going to divide when we have one term over one term. Now, if that's where we want to get to, how do we get things to one term? We factorize. So grade 12s, yes, there's tons of factorizing in this paper. You can't leave your factorizing behind in paper 1. Trigonometry is all about factorizing. So how would we factorize? Well, we see that we've got a common cos squared x. So we would take out, split your work, left-hand side, right-hand side. Grade 12s, you can't write left-hand side equals right-hand side at the outset. They've asked you to prove it. So we are trying to extract just the left-hand side. We're wanting to just simplify that and see whether we're actually getting it to the same as the other side. So left-hand side, we're going to take out cos squared x. So we're factorizing, we're taking out a common factor. What are we left with? Well, we've taken that out. So we're left with sine squared x plus, and we've taken cos squared x out. So we're left with cos squared x. Grade 12, tomorrow is your final paper. Check your work. If I multiply that by that, do I get back there? If I multiply a square by a square, do I get a fourth power? Yes. So just double check. It takes you a few seconds to do that. 1 minus sine x is in the denominator. We cannot divide if we don't have one term divided by one term. So I'm now ready. I can now, I've got now that bracket in the denominator. I can divide, but there's nothing to divide into because we're now sitting with cos squared x and we're sitting at, there we go, sine squared x plus cos squared x. What is that value? That value is 1. So we're left with cos squared x times 1 all over 1 minus sine x. And we go through that squared identity again. What is cos squared x equal to? It's equal to 1 minus sine squared x over 1 minus sine x. Now grade 12s, can we divide this sine x into that sine x? Can we do that? Can we divide that? The first question you have to ask yourself tomorrow is, can I divide? And the answer is, I can only divide if I have one term over one term. I have two terms. I can't divide. So your brakes to stop you from doing something is that question, can you divide, and when can you divide? I can divide when I have one term. If I don't have one term, what do you do to get to one term? We factorize. So we now have 1 minus sine x times 1 plus sine x. We factorize. Now I've created my compound term or my complex term, and I've got this denominator. Can I now divide 1 minus sine x into 1 minus sine x? Yes, because I've got just one term in the numerator. And so I'm left with this 1 plus sine x in the identity. Prove that for any angle theta, cos 3 theta is equal to 4 cos cubed theta minus 3 cos theta. Some of you said we did that in class. We know how to do it with our eyes closed. We're so excited we're getting that question for our exams. Well, we don't know if you'll see it in the exam tomorrow, but we'll certainly look at that solution straight after the break.
Thank you so much, Dina. I'm looking at the mindsetters communicating and chatting with me over the Facebook page, asking some interesting questions. But otherwise, keep them coming, mindsetters. Remember, you can also join our groups. We have a group for maths, which is called Mindset Maths. Go to that study group and get other mindsetters to help you. We'll see you after the break. Welcome back, awesome mindsetters. Now on the page, Dina, I'm seeing some great responses, such as this one from Studuzo saying, thank you, Mindset. I can now go write my paper 2, which used to give me hassles with confidence. Thanks to you. Thank you so much for such messages, mindsetters. Get ready. We're here for you.
Fantastic, grade 12s. All I want is you to just walk in there and just do the best. But remember, mathematician needs to look after its accuracy. So if the accuracy isn't there, then we're not going to be given any marks. So make sure you've got those alert caps on so we can really be very accurate. And I left you with that question, and I was really puzzled about that 23 that popped up on the screen. And it is, in fact, 2 to the power of 3 times 10 to the 2 to 5. That's what the supplementary question was about. So you may have said, whoa, I've never ever seen exponents written in trig notation. Well, Does it really matter that you've never seen it? That's what the mathematician does all the time. You get thrown with problems. And the beauty is in trying to solve those puzzles that you haven't seen before. So get excited that it's different. There's nothing there that you cannot do. The examiners can only ask you on the things, on the knowledge that you have. So what do you know about sine 150? We know that if it gets reduced to sine 30, then that's a special ratio. And we also know that tan 25 is a tan of 45. So can you see how these things actually become so simple? They literally just special ratios. So we've got 4 to the power of sine 30 is a half, times 2 to the power of 3, and tan 45 is just 1. They are special ratios. So 4 to the half, that's the square root of 4, is just 2. And then we're timesing that by 2 cubed. So we land up with the square root of 2 to the 4, which is 16, and the square root of 16 is just equal to 4. So something that looked complex because you hadn't seen it before, exponents and trig, please don't be thrown by what you see tomorrow. If it's different and exciting, get right into it. Ask yourself, what is it that you know about it? Okay, then I left you with that very interesting 3 theta. And I'm really going to do a little bit on it. Should you be given something of that sort. And the tip I'm going to give you is this. If they have said, write cos 3 theta just in terms of thetas, there's no formulae for triple an angle. You've got a formula for double angle, but you don't have for the double angle. So I would say that I would always break up 3 theta into something that I know. And I know that it can be written as 2 theta plus theta. So all of a sudden you've got a compound formula. And so you can break up that cos 3 theta into cos 2 theta multiplied by cos theta minus, remember accuracy, sine 2 theta times sine theta. And grade 12, it's a matter of just continuing. Just keep persevering until such time as you've got no more thetas. So we have a theta there, we've got a theta there, but you've got these doubles. And my question to you is, what do you think we should use? Because cos 2 theta's got 3 versions, so which one should we use? And I think we should go for the one, because I've only got cos thetas on that side, I'm going to go for the one with cos theta and see where we get to. So we've got 2 cos squared theta minus 1, and we're multiplying it by cos theta. And then sine 2 theta, fortunately, has only got 1 version. Okay? And let's tidy that up. Let's simplify, do the products, etc. So I'm getting 2 cos cubed theta minus cos theta minus 2 sine squared theta cos theta. Now, grade 12s, did you see it looked so complex, but look how tidy it's become. It's got all these thetas, I like it. Okay, and this is a minus, let's not think it's a plus, a times. So the only thing that we'd like to get rid of is that sine squared. So that's 2 cos cubed theta minus cos theta minus 2, 1 minus cos squared theta times cos theta. So we land up with a 2 cos cubed theta minus cos theta. And this is a 2 and a cos that's being multiplied in. So it's a minus 2 cos theta plus a 2 cos cubed theta. So we land up with a 4. I can see a 4 cos cubed theta. And I can see a minus 3 cos theta, because there are some like terms. So let's see what it was up there. There we go, 4 cos cubed minus 3 cos theta. Now, they've asked you to show that if x is 20 degrees, use question 3D to show that 8x cubed minus 6x minus 1 is equal to 0. I'll leave the mindsetters just to ponder that, because we've got a lot more to discuss before the end of the show, and I'd like to get through some of the important concepts in the trig graphs. And if we have a little bit of time later, I'll come back to that. Okay, so mindsetters, you can take that same question and try and show that 8x cubed minus 6x minus 1 is equal to 0. Okay, so we now have next question. There we go. All right, trig graphs. Here we go. Trig graphs, my favorite, because you can do a lot of thinking in this question. It's not like in history, we have to write for 1 or 2 marks. Here, you can do lots of thinking, no writing, and get lots of marks. So that's what I love about trig graphs. Okay, so what are we given with a trig graph? We've got f of x is sine 2x, and we've given it over this domain, and the graph is actually shown below for us. So I'm just going to draw the x-axis so we can see it clearly. There it is, x-axis, and there's my y-axis. So grade 12s immediately you should be telling me, okay, I know what's happening. Double the angle. What's going to happen to the graph? Okay, its period would have been affected by the period of the parent graph is 360, so we divide that by 2 and we go 180, which means that our maximum is now happening at 45 degrees. Look at what's happening, maximum at 45 degrees. So it's 45 degrees 1. Okay, out of the 4 transformations, the amplitude, the vertical translation, the horizontal translation, the period one is the one where things are shifting. They are happening at a different time. But they are happening so that when you multiply 45 by 2, you get 90, so you get back to the parent graph's value. And the parent graph says that at sine 90, you're going to get the value of 1. So there we go. So we know that that's at 45, that's at negative 45, and that's at 135. So we're getting a full sine curve. How many degrees does it take to complete a sine curve? 90 and 90. There we go. So it takes us 180 to complete the sine curve. The period is now 180. So as you get given that graph, your head is thinking through all these things. Number one, what is the period? What is the new period? What are you expecting your curve to be doing over that period? It's going to have a max, a 0, a min, and a 0, and it's going to take that 180 degrees to create that full curve. Okay. Write down the range of f. What is the range? The range is the set of y values. Let's just revise that. Range is the set of y values. How do you remember that? They really are alphabetical. So your domain is the set of x values. If you see dr, xy, they really are all alphabetical. So the range is what is the smallest to the largest value. So my range of f goes from -1 all the way to +1. Smallest y to the largest y is 1. Right, now we change the function slightly. We say the graph is y equals sine 2x. Okay, but now we want to find out what is the function value of 3 over 2x. So it will be sine of 2 multiplied by 3 over 2x. So we get the sine of 3x. So if you apply this rule, then what you're going to have is that you've got a sine 3x as your new function. So the question is, determine the period of the new function. Well, we first needed the function. So the function is sine 3x. The period of the parent sine curve is always 360. So the period of the new graph is going to be 360 divided by 3, by the coefficient. So this coefficient is the coefficient that you divide by, so you get the new period is 120 degrees. So that would be that new function. Then they want us to draw the graph of a new function, cos of x minus 30. Fantastic. What's happening to that curve? Is it moving up, down? Is it moving left, right? And now it's not the sine curve anymore, it's the cos curve. So we can really revise both the sine and the cos function here this afternoon. For the same period, on the same system of axes, and clearly show all the x-intercepts and turning points. So let's go there, grade 12s. Let's actually go on to the next page. Right, the next page. No, next page. There we go. So we've got that graph, and let's just draw, that's the x-axis. Right, and if that's 45, then can you see I've got 1, 2, 3, 4, 5, 6 values between 0 and 90. So therefore, each one of these is a 15 degree, where that's 45, and that's minus 45. So I know each one of those is 15. Right, we would like to draw the graph of y equals cos. Actually, let's call it by name. So we're referring to the same thing. And we had a blue one, so it's g of x is equal to cos of x minus 30. Grade 12, the only thing you need to remember for tomorrow, if there's a translation, we need to know if it's up, down, left, right. Okay. Any translation on x is something that's happened along the x-axis. Okay, that's the best way to remember that. And you've just written paper 1. You've done all the translations, left and right, of your parabolas, of your hyperbolas, of everything else. The same thing applies to your trig function. It has translated to the right by 30 degrees. How do we know that? Because the value that you substitute in here, when you take 30 minus 30, you need to get 0. If you don't get 0, you haven't then translated from 0. So let's always substitute in a value to make sure that you get a naught. So x minus 30 means I've moved right by 30 degrees. So I'm going to start my graph at 30 degrees. What happens at 30 degrees? My cos graph exhibits a maximum because 30 minus 30 is 0, so cos of 0 is 1. So there's my cos graph at 30 degrees. And then I can go to 90 and I can say, well, at 90 degrees, it would be 90 minus 30, which is 60. So the cos of 60 degrees is a half. So that's where it stops because it can't go beyond that 90. Then I'm going to go back 90 degrees. So from 30, that would be 30, 60, 90. So that would be 90 degrees, which would be at negative 60. And that's where I would get my 0. Okay, so 90, actually this isn't 90, this is negative 60 minus 30 would be negative 90, and the cos of negative 90 would then be 0. So my cos graph goes there, and then 90 degrees later would be 30, 60, 90. There I would get a minimum. So I would get a minimum value there, and at negative 180 minus 30, I would get negative 210, and the cos of negative 210 would be the same as cos of 210, which would just be root 3 over 2, which is 0,88. So you would put it over here. Now, we go back to the instruction, because it's very important how you answer it, otherwise you lose marks. It says, clearly show. They want to see all the x-intercepts and all the turning points. Sometimes they also add the endpoints. Okay, because that's how the markers are going to give you marks for this question, the endpoints. So let's go to the endpoints. Let's go forward. There we go. So we want to see those endpoints. So here's my graph. It's going to go okay, so it's going to cross there and it's going to go there. So my graph is going to do that. Go through 1 and then go down there. Okay? And then here, okay, yeah, I thought this point was not in the right place. It's negative 8,66. This is negative 1, so it's more closer to there. So this point would be the point negative 180 degrees and minus root 3 over 2. And the graph just goes there. That's better. Okay. So we can see that we have an intersection over here, and we've got an intersection over there, and we've got an intersection over there. And I can bet you that the examiner tomorrow is going to want to know where those intersections are. We've just mentioned earlier, how do we know when two graphs intersect? When we solve simultaneously. So let's go and see what the last question is. Oh, we haven't done D yet. Hence or otherwise, determine the values of x in the interval that, for which, here's something quite interesting. What does this say? This says, where is y of f times y of g negative? Where do we find where the product of the two graphs, where is the product of the two graphs negative? In grade 11s, I don't have a vertical something to work with here, and if I had a piece of paper, let me just check here. I think this will work. Let's look at the white graph and the blue graph. Can you see that if we take the white graph times the, and when I say times, I'm talking about the y value. That y value is positive because it's above that yellow line. That y is negative. So if we multiply the two together, can you see we're getting a negative? If you keep shifting this piece of paper along, if only it would cooperate. There we go. If I shift this piece of paper along, it does not change. It's still positive, it's still negative, it's still positive, it's still negative. But then something changes here at that intersection. So we now have that at that intersection, this white becomes now negative and this blue is negative. So their product is actually positive. And can you see that it doesn't change until it gets to that blue again? Now the blue becomes positive and the white becomes negative. And so along that region, they don't change until naught, because then they're both positive. Okay, so just take your ruler and work your way from left to right, finding out what is happening. When will the signs change? They will change when the graphs cross the x-axis. So something's happening there, something's happening there, something's happening there, and then finally at the end. So the product is positive, and I'm going to draw a little set builder notation. So not positive but negative. From there all the way to this value here. Okay? Let's just check that out. Right, so we've got up to this 90 here. Okay, then we've got those values, right, and then we said from that value there. When the graphs are different y values, and then they change over here, and they stop there. So this set of numbers, the product of those values will be negative. Between there and there, they will both be negative, so they will give us a positive product. And then between there and there. And then we notice that in this area here, they're both positive. So we're saying that in order for us to get a negative product, we are wanting an x value to go between two sets, or we've got another x value between two sets. Let's go and see what that value is between negative 180 and negative 90. And we wanted a negative product, so I'm not including those values. And then we want from negative 60, because that's where it crossed the x-axis, all the way through to 0 degrees. So those are the two sets. So negative 180 through to negative 90, or negative 360 through to 0 degrees. And grade 12s, please don't spend time for these 4 marks trying to solve this thing algebraically. You are going to go completely out of your head if you're going to try and solve it algebraically. Try and use your graphs. That's why you've sketched them. Okay. So we spoke about our orange. Our orange are the points of intersection. Let's look at the next question. Describe the transformation that the graph f has to undergo to form that graph y equals 2x plus 3. Okay, grade 12s, don't forget that your transformation with a translation has got to happen where the coefficient of x is 1. So if they're going to ask you what transformation it has undergone, you would have been tempted to say it's been translated left by 60 degrees. But remember, grade 12s, that your transformation has got to happen when the coefficient of x is 1. Very, very, very important. So the transformation is a translation left by 30 degrees. Okay, remember that we change the opposite direction to the actual constant, and it's not left by 60 degrees. The coefficient of the angle has to be 1 for us to have a horizontal translation. Okay, and then determine the general solution. Aha, so they didn't actually want our orange bits, they actually wanted our general solution of sine 2x is equal to cos of x minus 30 degrees. Now, it's very difficult for me to be here in the studio and to be sharing with you how to do this, because some of you are very happy to do it in your own particular way. The only thing I'm going to guard against tomorrow is when you ask for a general solution, make sure that you're bringing your terms together. Make sure you're bringing each and every term into a factorized form, because the only way you can solve for an equation is if you've got factors, whether you've got the complex trig expression or whether you have the sine equals the cos. Because this afternoon we're running out of time, I'm not going to look at all those versions. I'm going to look at the one that I believe is possibly the quickest and most efficient way of finding the general solution when you've got a sine and a cos function. Because we know the relationship between the sine and the cos function is 1 where the sum of the angles is 90 degrees. So they are very special functions. And I'm going to use that notion of the 90-degree angle to work with sine 2x and to say, grade 12s, are you happy that the cos of 90 minus 2x is the same function as the sine of 2x? Do they give us the same value, the same trig ratio? And you'd be saying yes, because if we add up their angles, we get 90, and cosine is the cofunction of sine. So therefore, that would work. So we would then get equals to the cos of x minus 30. And why do I like that? Because I really enjoy working with a cos function. It's the function that exhibits symmetry about 0 degrees. So the cos of a is the same as the cos of negative a. And that's the only function that exhibits that symmetry. All other functions, the inverse is what happens. So you've got sine of a equals negative sine of negative a, for example. So really, I like to change into a cos function. There's less arithmetic involved with it as well. That's why I call it the more efficient way. So I've used the cofunction here, and then I'm saying that if my cofunctions are true, then my angles must be true. So this angle must be the same as this angle, firstly. So 90 minus 2x must be equal to x minus 30. And remember, grade 12s, that it happens periodically. So when you say an angle is equal to another one, you are saying that for every 360 degrees after that, that would still hold. So it's got a period of k360. I'm also saying that the cos function also has the property that your angle 90 minus 2x is also equal to the additive inverse of 30 minus x plus k360. Now, some of you will refer to this as the angle, the angle, or you will refer to it as 360 minus x. Grade 12s, at this stage, you should have already formulated that when we're in quadrant 4, we have different ways of expressing the angle. We can say 360 minus a reference angle, or we can talk about a negative angle, the negative coterminal angle. So there are various ways in which you can describe it, and it depends what you feel comfortable with and what you've learned. But for me, the most important thing is, and I'm going to put it as a little note here, because this is quite intense statement right here, is I'm going to say that I'm going to use that if cos A is equal to cos of negative A, okay, that's the first thing, that A is equal to negative A. And in other words, if I'm being given two angles, the value of the angle is itself A, or it could be negative A. That's where I'm getting that second angle from. So if I have cos A, for example, is equal to cos 30 degrees, then what I'm saying is that A can be 30 degrees and multiples of 360, or A, because cos A equals cos negative A, is also equal to negative 30 plus k360. But negative 30 is the coterminal angle of 330 degrees, so I could also call it A is 330 degrees. Remember that you're adding on multiples of 360, so those angles are all going to be found whichever way you use it. Okay, so now to go back, okay, so these are my like little notes that you can use, and we need to now go back to the fact that we've got an equation to solve over here. So you now practically collect your x's. So negative 2 minus x is negative 3x, and that's equal to negative 30 minus 90 is negative 120 plus k360. Grade 12s are in the habit of just, you do your question and then you slot in the k360 at the end. That is incorrect. As soon as you've taken the angles out of the trig ratio, you need to insert your period at that stage. That's quite important. So we then get an x value of 40 degrees. I'm dividing by 3 on both sides, minus k120. Can you see that now, because I had a coefficient of x, my period has been adjusted. So you can't just now slot in plus k360. That's not the correct period. Okay? Or from the other side, from this side here, we have negative 2x plus x is just a negative x, and we've got a 90 that we're taking over that side. So we get equals 30 minus 90 is minus 60 plus k360. And if we now solve for x, x is equal to 60 minus k360. Okay, now they've just asked you for the general solution. They haven't asked you to go and find the specifics. They may, and if they do that, they'll give you another 3 marks for going to find the specific values. But just for our interest's sake, let's see if 40 and 60 are in fact those intersections. And let's go quickly up here. Can you see? It's intersecting just before 45. So that's our 40 degrees that we found. And can you see it's intersecting just after this line over here, or on that line over there? So that would be your 60. And then if I take our 40 and I minus our 120, I get negative 80. And can you see our negative 80 is over here? And that one, if I added on a period of 360 or minus, I'm not getting any solutions in that value. But I'm very glad that our general solution does give those values. And tomorrow in your exam, if you work out your general solution and you work it out back to your graph, if you're actually getting the two things to match, it will be like a trial balance in accounting. It will make you so happy because you know that your graph and your equation have come together to unveil where they're actually intersecting. So I think on that note, we'll take a quick break.
We'll end it there, Dina.
Is that the end of the show?
We have to end it.
At the end of the show?
Yes.
Oh my goodness, okay.
Time is
Time out.
flying.
Good luck, grade 12s. Good luck.
Good luck to all grade 12s. Otherwise, don't let fear come across you because you need to be ready. And we know that with Mindset, you are definitely ready. Go and ace it because we believe in you. Otherwise, from us to you, peace and thank you.